Welcome folks. In this video, I'm going to show you how to convert points from polar form to their corresponding rectangular coordinates. In order to be successful with this, you have to be really good at graphing points first. And second, you really have to be secure in your knowledge of those special right triangle relationships. So if you feel you're lacking in either of these areas, or if you're on shaky ground, my advice would be to go back and rewatch those videos. Get yourself feeling comfortable and confident and secure so that you can be really sure of what you're doing in moving forward. All right, let's go ahead, let's get this party started. In part A, it's asking us to plot point Q, whose radius has length -6 and whose angle measure has measured -5 pi over 6. So I'm going to come over here to my positive x-axis or my polar axis. That negative in the angle measure tells me that I'm going to have to move in a clockwise direction, 5 pi over 6. So 30 degrees is going to be 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So the terminal ray is going to end up there on 210 degrees. I'm now going to go plot my radius length of -6. And just a brief reminder that the negative in the radius length tells us to go ahead and to reflect through that pole. So I'm going to go ahead and reflect through the pole. And I want to count out a distance of 6 on that ray. 1, 2, 3, 4, 5, and 6. So there, folks, is where point Q is going to end up. All right, to keep things simple and to keep my picture simple, I thought I was going to go ahead and erase, but I think I'm not going to. I think I'm going to leave that in there. Moving on to point B, part B. Draw a line segment from point Q down to the x-axis. I'm going to be a little more specific about that and say I want to draw that in such a way that it forms a right angle with the x-axis, and then label the sides of the triangle with their lengths. So the one thing I know from plotting the point here is that my radius has length of 6. So I'm going to come up here and label this with a 6. I know that this angle in here is 30 degrees, and I know that in the 30, 60, 90 right triangle, the side lengths are in the ratio 1 to √3 to 2. So what I'm given for this right triangle is I'm giving that hypotenuse, or the radius length, of 6. And working backwards, I know that hypotenuse is always double the length of the shorter leg. So that means that the leg opposite 30 has to be 3. And then that middle number has to be the first number times √3. So 3√3. So the side lengths of my triangle here are 6, 3, and 3√3. Believe it or not, we're almost at the finish line here. Part C wants to know what would be the rectangular coordinates of point Q. Well, if I look at point Q is located 3√3 units to the right of the origin and 3 units up from the x-axis, making his rectangular coordinates 3√3 because that's how far we moved in the x direction, and 3 is the number of units moved in the y direction. So his rectangular coordinates, 3√3, 3. Whether you realize it or not, we just converted a polar point to a rectangular point, and it really wasn't that hard. That's going to be my method for all of the points that we're going to convert today. All right, that said, the method that I'm going to use to convert those points is one possible method. A second possible method involves some formulas that we're going to derive here in that yellow box. It says to convert to and from the polar system to the coordinate system, it says you must know the following relationships. I'm going to amend that to say you can use. And in fact, later on in the unit, when we convert polar equations back to coordinate, or coordinate equations back to polar, we're going to use all of these relationships. But for today, I just want you to be aware that you can use all of those. You don't have to, you just can. All right, that said, I'm going to move on, and down at the bottom at number 1, or in number 1, it says convert the polar points to rectangular coordinates. Use exact values only. I'm going to cross off where it says unless using a calculator because we're not going to use the calculator. All right, keep in mind, I'm going to use triangles and circles. But again, you could also use those formulas that are up there in that yellow box. I'm not sure which method Delta Math uses. I just want you to be aware that the method that I'm showing you is one possible method, but it is not the only possible method. So in order to convert using triangles and circles, first thing I'm going to do is I'm going to plot the polar point. So number 1 has an angle measure of 90, radius of length 6. So he's going to be right up here. Once I plot him, now I just need to name his coordinates in the rectangular plane. So that point is located 0 points or 0 units to the left or right of the y-axis. It's up 6 units from the x-axis. Its rectangular coordinates are 0, 6. Far easier than finding those using the formulas in the yellow box above. Letter B says find the point with coordinates 4, 60 degrees. So again, first thing I'm going to do is plot it. This 60 degrees is going to end up in quadrant 1. Radius length is 4. 60 degrees tells me my reference angle here is going to be 60, which is going to make this angle 30. So I'm looking at my 30, 60, 90 right triangle. And in that 30, 60, 90 right triangle, the length of the hypotenuse will always be double the length of the smallest side. So that means my shorter leg has to be 2. My longer leg then is 2 root 3. And again, I'm using that 1 to root 3 to 2 ratio. So in order to name that point is 2 units to the right of the origin, 2 root 3 units up, making his rectangular coordinates 2, 2 root 3. Once you get the hang of these, they really start to get fun. Letter C says convert the point 10, 225 degrees. So again, I'm going to start by drawing that triangle. He's going to be in quadrant 3. So my radius length here is 10. My angle measure is 45. That makes this the isosceles right triangle. And remember the relationship there in the isosceles triangle is 1 to 1 to root 2. So if I know my hypotenuse, in order to get back to the length of the leg, I'd have to divide by root 2. So this makes each of these legs 10 divided by root 2. They are to the left of the origin, so negative, and moving down from the x-axis, so negative. And that makes my coordinates negative 10 root 2 over negative 10 root 2. Just a heads up that if you were going to input this into Delta Math, remember that Delta Math does not like irrational numbers in the denominator, so you would have to rationalize those denominators before putting those answers in. All right, we are moving. Letter D says 3, 120. So first thing I'm going to do is plot it. And again, that radius length is 3. The angle measure of 120 tells me that that reference angle is 60, making this 30. And now I can go ahead and use my ratio 1 to root 3 to 2 to label the sides of this triangle. So I know this hypotenuse is going to be double the length of the shortest side. So the length of the shortest side is either going to be 3/2 or maybe 1.5. Either one of those is a good way to express your answer. And then that longer leg is going to be that leg 3/2 times root 3. I'm going to go put some signs in there. That 3/2 was to the left of the origin, so I'm going to make that negative. And then this number is up from the x-axis, so going to be positive, making my coordinates here negative 3/2 for x. And you can either write 3/2 root 3, you can write 3 root 3 over 2. All of those you could write 1/2 root 3, sorry, 1.5 root 3. Those are all different ways to name that same coordinate. You'd get credit for any and all of those. All right, I don't know about you guys, I am having fun. Letter E says 8, 210 degrees. So 210 degrees is going to put me in quadrant 3. Radius length here is 8. Reference angle here is going to be 30. I'm going to go ahead and draw my right triangle. And again, I'm living in that 30, 60, 90 right triangle. So with that ratio 1 to root 3 to 2, where I know that the hypotenuse is 8, it's also double the length of that shorter leg. So that leg that's opposite the 30 degrees has to be half of that hypotenuse, or 4, making the remaining leg 4 root 3. I'm in quadrant 3, so both the x value and the y value are negative. So it looks like I've moved 4 root 3 to the left of the origin, then down 4, making my ordered pair here negative 4 root 3, comma, negative 4. Letter F has a calculator, so we're going to skip that. Boy, that one was easy. I like that one. All right, moving on to letter G. Letter G says 5, comma, pi. So pi radians is going to put me over here on the negative x-axis at a distance of 5 units from the pole. So the name of my xy coordinate, that's 5 units to the left of the origin and 0 units up and down, negative 5, 0. Ooh, I like that one. I like those ones that end up on the axes. Letter H says 2 root 3, comma, pi over 6. So I'm going to go ahead and plot that, or label that angle, pi over 6. My radius length is 2 root 3. Sketch my triangle. And it looks like I'm working in the 30, 60, 90 right triangle again, making that ratio 1 to root 3 to 2. So I know the length of that hypotenuse is 2 root 3. I know that that is double the length of that shorter leg, or the smallest side. So half of 2 root 3 is going to be just root 3. And again, if you can't mentally do that, 2 root 3 divided by 2 just gives you root 3. And then that middle side is going to be that shorter side of root 3 times root 3. And root 3 times root 3 is root 9, which is really just 3. So that remaining side is going to be 3. So if I look at my point, he's 3 units to the right of the origin, root 3 units up. He has coordinates 3, comma, 3. All right, letter I says 5/2, comma, 5 pi over 3. So plot it. 5 pi over 3 is going to take us to quadrant 4 with a reference angle of pi over 3, radius length of 5/2. If you prefer 2.5, you're more than welcome to use 2.5. I'm going to draw my right triangle in here. My remaining angle is pi over 6. So again, I'm in that 30, 60, 90 right triangle, or that 1 to root 3 to 2 ratio. My hypotenuse of 5/2 is going to be double the length of that shorter leg. So I'm going to take the 5/2 and divide it by 2. And in dividing 5/2 by 2, I'm going to remind you that dividing by 2 is the same as multiplying by its reciprocal of 1/2. So that side opposite pi over 6 is going to have length 5/4. The remaining leg is going to be that 5/4 times root 3. So it can either be 5/4 root 3 or it can be 5 root 3 over 4. Two different ways to name the same thing. The 5/4 is to the right of the origin, making that value positive. I'm moving down from the x-axis, making the y value negative. So my ordered pair here in the xy plane is going to be 5/4 negative 5 root 3 over 4. Wow, we get special right triangles, we get fractions, we get ratios. This is some really fun stuff. I'm having fun. I hope you folks are too. Letter J says 6 comma pi over 2. So pi over 2 is going to put me up here. I'm going to use or move 6 units up. So there's my point. So I've moved 0 units left and right, 6 units up, making that ordered pair in the xy plane 0, 6. And again, I love those that end on an axis because I don't have to worry about my triangles and it makes them just a little easier. All right, maybe a lot easier. All right, letter K, negative 1 comma 7 pi over 4. So when I start with that angle, I'm thinking that angle is going to take me into quadrant 4. And that would be 100% absolutely correct. But the negative value on that radius is going to drive me 180 degrees or reflect through that pole, reflecting me back up into quadrant 2. So my reference angle here is pi over 4. I got so excited about that reflection that I can't read my radius length, so I'm going to have to go back and erase. Oh, it was 1. Okay, so this length here is 1. So looks like I'm in the isosceles right triangle or the 45, 45, 90 right triangle. His ratio is 1 to 1 to root 2. So this guy here represents the root 2, meaning to go backwards, I'm going to have to divide by root 2. So each of these legs are going to be 1 divided by root 2, or 1 over root 2. I'm to the left of the origin, making this one along the x-axis negative. Moving up from the y-axis makes that one positive. So my ordered pair here is negative 1 over root 2, comma 1 over root 2. And again, if you were to enter that into delta math, make sure you rationalize your denominators first or you're going to end up with the angry red X. All right, my goal was to finish in 20 minutes or less, and it looks like I'm going to make it because we are approaching the finish line. Letter L says negative 4 comma negative pi over 3. So negative pi over 3 is going to take me clockwise pi over 3 radians, taking me there into quadrant 4, but the negative in front of the radius is going to reflect that through the pole, making that reference angle pi over 3 and that radius length 4. So that means that once again I'm in my 30, 60, 90 right triangle with its ratio of 1 to root 3 to 2. Radius length here is 4. The shorter leg is going to be half of that, or 2. So opposite pi over 6, I've got 2, making that remaining leg 2 root 3. So it looks like my coordinates for this point are negative 2, comma, positive 2 root 3. All right, folks, and that is it in a nutshell. That is converting polar to rectangular. Once you know how to plot points and you know those special right triangles, it is not that hard. But again, if you need to go back and revisit the special right triangles, my advice would be to do that before you try to attempt the homework on these types of conversions. As always, your time and attention is greatly valued and appreciated. Till the next time that we see each other, peace out.